Choosing an experimental home built isn't about specifications or magazine reviews. It's about matching metal and composite to your personality, your mission, and the kind of pilot you truly are rather than pretending to be. Today, we decode 10 radically different experimentals, revealing which aircraft fits your soul. Welcome to Which Experimental Home Built Fits Each Type of Pilot. Every Cessna rental flight ends the same way. You taxi back, wishing the controls felt alive instead of vague, wishing climbs impressed passengers instead of inducing yawns, wishing something about flying felt visceral again like it did during your first lesson. Certificated aircraft manufacturers optimized for lawyer approval and production line efficiency, not for pilots who remember why they learned to fly in the first place. Organ designer Dick Van understood this frustration intimately when creating an aluminum two-seater that would make formation flying, weekend aerobatics, and cross-country speed feel accessible rather than reserved for the wealthy or reckless. The Van's RV-8 emerged as the aluminum answer, proving home builders could achieve fighter-like response without fighter budgets or military pedigrees. Like homing, producing 180 to 200 horsepower push, the tandem configuration through air at 170 to 175 knots true airspeed while sipping 7.5 to 8.5 gallons per hour. Climb performance exceeding 2,700 feet per minute. At lighter weights, transforms departures from procedural necessities into opportunities for showing off to friends still flying rental spam cans. The +6, -3 G structural limits accommodate sport aerobatics, including loops, rolls, and Cuban 8s that certified aircraft prohibit even when structurally capable because liability concerns override pilot enjoyment. Pre-punched aluminum kits eliminate the guesswork and frustration that plagued earlier home builders forced to fabricate every part from raw materials and vague drawings. Riveted 2024 T3 aluminum construction uses techniques any dedicated builder masters within weeks, rather than requiring aerospace engineering degrees or machine shop access. Thousands of completed RV-8s flying worldwide created the largest experimental aircraft community in history, where any construction question receives multiple detailed answers within hours, and transition training remains readily available at reasonable costs. Insurance companies actually want to cover RV-8s, given the type's safety record and established training infrastructure, with annual premiums reflecting reality rather than experimental category paranoia. Values range $60,000 to $120,000 United States dollars, depending on engine choice, avionics complexity, and finish quality with strong resale demand. But tandem seating and aluminum construction satisfy only certain personality types, while others demand something far more extreme and historically significant. Childhood memories burn permanent, standing at the fence line when a P-51 Mustang roared overhead for the first time, feeling the Merlin's 12-cylinder growl shake your chest cavity, watching that elliptical wing slice through air like a knife through silk. Decades pass, but the moment refuses to fade, growing stronger during every air show, every documentary, every quiet moment when you admit to yourself that nothing else in aviation will ever satisfy quite the same way. Rational adults abandon this obsession and buy sensible experimentals, but certain individuals refuse rationality when their soul demands authenticity, even if achieving it requires years of complex construction and six-figure investments. The Thunder Mustang exists specifically for these individuals who reject compromise when childhood dreams become achievable through 3/4 scale carbon fiber engineering. Ryan Falconer's custom V12 engine displacing 601 cubic inches generates 640 horsepower at 4,500 revolutions per minute, liquid-cooled and naturally aspirated, driving a 94-inch MT4 blade constant speed propeller. This powertrain combination produces climb rates exceeding 5,000 feet per minute, and cruise speeds ranging 260 to 300 knots, depending on altitude selection and power settings. Race-prepared examples at Reno Air Races recorded lap speeds near 400 miles per hour, proving this experimental competes legitimately against purpose-built unlimited class racers, rather than merely looking fast while disappointing during actual flight. Carbon fiber and graphite monocoque construction demands skills far beyond typical homebuilder experience levels, where every layup, every cure cycle, every structural detail directly affects whether the aircraft flies like a thoroughbred or becomes an expensive hangar ornament. Retractable conventional landing gear, liquid cooling systems with radiators and adjustable cooling doors, high wing loading approaching operational limits, and 3,200-pound gross weight create an unforgiving machine that punishes pilot errors swiftly and decisively. This represents the opposite of forgiving trainers, where sloppy technique merely produces poor landings rather than actual danger. Kit pricing starts around $250,000 United States dollars before adding engine, avionics, paint, instruments, and approximately 3,000 build hours by someone genuinely competent with advanced composites. Completed examples rarely appear for sale because builders who finish Thunder Mustangs typically refuse to part with them regardless of financial offers. While some chase authentic warbird aesthetics, accepting extreme complexity, others prioritize pure speed in packages designed from conception for velocity rather than nostalgia. Marriage counselors probably encounter this scenario regularly. One spouse wants exciting weekend adventures, while the other demands comfort, safety, and arrival times predictable enough for dinner reservations. Certificated aircraft force, choosing between these priorities as manufacturers, build either fast, uncomfortable machines or comfortable, slow ones, never both simultaneously. The composite revolution finally solved this decades-old compromise by enabling shapes impossible in aluminum where aerodynamic efficiency and spacious cabins coexist rather than conflict. Speed no longer requires cramped cockpits, deafening noise levels, or apologizing to passengers after every flight. The Glasair III synthesized these competing demands through full composite construction, where 300 horsepower meets two-place comfort in a package, cruising faster than most singles certified for instrument flight rules. Lycoming I-0540 engines displacing 540 cubic inches and producing 300 horsepower drive. The side-by-side configuration between 210 and 225 knots true airspeed at altitude while maintaining fuel flows that surprise pilots accustomed to certified aircraft burning substantially more for significantly less speed. Maximum velocity approaches 300 miles per hour with never exceeds speed around 335 miles per hour, providing comfortable margins during high-speed cruise. Empty weight near 1,650 pounds, against maximum gross weight approaching 2,400 pounds delivers useful load exceeding 700 pounds, accommodating full fuel, baggage, and 2 adults without weight and balance gymnastics. Retractable tricycle landing gear integrates completely into the composite fuselage, and wing structures eliminating parasitic drag that fixed gear designs accept as inevitable. 65 gallons of fuel capacity enables range exceeding 1,000 nautical miles, transforming the Glasair into legitimate cross-country transportation rather than fair-weather recreational toy. Climb performance between 20, 100, and 3,000 feet per minute, depending on weight and density. Altitude makes instrument departures and obstacle clearance trivial rather than stressful calculations. The low wing configuration, with relatively small area and thin airfoil sections, prioritizes high-speed efficiency over short field performance. Completed examples command $150,000 to $250,000 United States dollars, reflecting substantial material costs and skilled labor investment. Composite speed impressed many builders, but engineering purists believed polished aluminum could equal those numbers through obsessive aerodynamic refinement and meticulous construction. Airport conversations reveal a peculiar tribe. Engineers who discuss Reynolds numbers during breakfast, calculate induced drag on napkins during lunch, and debate boundary layer transition during dinner as though these topics were sports scores or weather reports. These individuals don't simply want fast aircraft, they demand aerodynamic efficiency that defies conventional wisdom, where stubby metal eggs somehow cruise faster than sleek composites twice their size. The Questair Venture materialized this engineering obsession through aluminum construction so meticulously refined that every rivet, every surface junction, every transition received obsessive attention, eliminating drag that other designers accepted as inevitable compromise. Continental IO550G engines displacing 550 cubic inches and generating 280 horsepower drive. The compact airframe to cruise speeds around 240 knots true airspeed at 12,000 feet while consuming approximately 13 gallons per hour. Stretch-formed aluminum panels create the distinctive rounded fuselage with minimal wetted area, while countersunk rivets maintain aerodynamically clean surfaces. Maximum speeds exceed 250 knots indicated with race examples, recording velocities between 275 and 300 miles per hour. Range approaches 1,000 nautical miles at maximum cruise, proving efficiency translates into practical capability. Market values reflect rarity and performance, with completed examples commanding $70,000 to $130,000 United States dollars. The Questair Venture proves that unconventional thinking combined with meticulous execution creates results that textbooks suggest impossible until actual flight data forces updating assumptions. Completed examples rarely appear for sale as builders who finish ventures typically refuse parting with aircraft that consistently embarrass faster-looking designs during cross-country races. Insurance companies initially viewed the type skeptically, but growing operational experience demonstrated reasonable safety records when flown by competent pilots respecting the performance envelope. While some pursue efficiency through mathematical precision, others believe visual impact and construction craftsmanship matter equally when creating personal aviation statements. Sheet metal perfectionists share common traits. They measure twice and cut once, they obsess over rivet patterns achieving geometric precision, they polish aluminum until surfaces reflect like liquid mercury, and they refuse accepting that composites monopolize high-performance experimental aviation. Ed Swearingen embodied this perfectionist philosophy when designing a two-seat aluminum speedster, proving that traditional materials achieve composite velocities when construction quality reaches near obsessive levels. The Swearingen SX-300 vindicated aluminum construction through meticulous engineering, where 40,000th-inch wing skins and 20,000th-inch tail skins combined with stretch form leading edges, creating surfaces smooth enough for maintaining laminar flow. Lycoming IO540 engines, producing 300 horsepower from 6 opposed cylinders, push the low wing configuration to cruise speeds around 240 knots at 8,000 feet with 75% power. Countersunk rivets throughout the structure minimize surface disruptions, while retractable tricycle landing gear fully fares into fuselage and wings, eliminating fixed gear penalties. Range approaches 1,100 to 1,150 nautical miles, with 45 minutes reserve fuel from 60-gallon wet wing capacity, enabling coast-to-coast travel. Build quality separates successful projects from disappointing ones, where sloppy riveting directly impacts cruise performance and fuel efficiency. Market values reflect quality variance, with exceptional examples commanding $120,000 to $180,000 United States dollars. The SX-300 proves metal construction remains viable when execution reaches professional standards that most amateur builders never achieve despite best intentions. Weight control becomes critical during construction, as every unnecessary pound added directly reduces useful load or requires accepting reduced performance. Perfectionist builders achieve advertised speeds, while rushed construction produces aircraft performing substantially worse during actual flight. Metal purists prove their point convincingly, but certain personalities reject choosing between materials, preferring instead to combine aluminum heritage with substantially more engine than sanity suggests necessary. Van's RV builders eventually divide into two camps: those satisfied with excellent performance from reasonable engines, and those wondering what happens when you stuff absurdly oversized power plants into airframes designed for half that output. The second group doesn't merely want adequate climb rates or respectable cruise speeds, they demand acceleration pinning passengers into seats during takeoff rolls that seem impossibly short. Hot rod culture always valued overkill over optimization, where excessive power becomes the entire point rather than embarrassing mistake that responsible adults would avoid. The team, Rocket F1 Rocket, embraced this muscle plane philosophy by reinforcing RV4 derivatives, accepting Lycoming IO540 engines, producing 260 to 300 horsepower in tandem configurations, weighing approximately 1,200 pounds empty. Maximum speeds approach 250 miles per hour with cruise speeds around 230 miles per hour or 200 knots at 10,000 feet. Climb rates reaching 3,500 feet per minute at sea level transform departures into nearly vertical ascents that general aviation pilots witness with a mixture of admiration and envy. Range extends approximately 1,000 statute miles at 55% power, while short field performance enables takeoffs within 300 feet. The conventional fixed landing gear with titanium legs and tailwheel configuration prioritizes simplicity and strength over retractable complexity. Reinforced aluminum structure handles substantially increased loads from oversized engines and aerobatic maneuvering within +6 - -3G limits. Construction familiarity exists throughout the Vans builder community, where techniques and troubleshooting knowledge transfer directly from RV projects. Market values range based on engine choice and equipment levels, with typical examples between $80,000 and $150,000 United States dollars. While American builders created muscle planes through brute horsepower, true believers in alternative configurations pursued speed through radical departures from conventional designs that casual observers found either brilliant or insane, depending on perspective. Burt Rutan's canard pushers created a cult of pilots who see conventional layouts as tired compromises. For those true believers, the Berkut 360 becomes the ultimate escalation of the long E-Azid idea, built in carbon fiber with heavy structural reinforcement. It accepts Lycoming IO540 engines in the 280 to 308 horsepower range and a sleek tandem pusher airframe with retractable landing gear. In level cruise, the Berkut routinely runs beyond 220 to 230 knots, and carefully optimized examples edge toward 300 miles per hour. Race-tuned aircraft in Reno Silver class have logged lap speeds around 260 miles per hour, proving this is not just an efficient cruiser, but a legitimate competitor. The canard is designed to lose lift first, keeping the main wing away from a full stall and reducing the chance of a sudden spin entry. Retractable nose and main gear remove the drag penalty that fixed gear canards must accept, trading mechanical complexity for pure speed. The price is paid in the shop. Builders work mainly with carbon fiber skins over high-density foam cores, a demanding composite process, far from simple aluminum sheet riveting. Completed Berkuts are rare and expensive, often valued between $90,000 and $160,000, the purest expression of canard philosophy for pilots who refuse to fly anything conventional. Many aviation households split between the spouse who craves adventure and the one who wants comfort, predictability, and solid safety margins. Certified designs usually force a choice between fast two-seaters or slow four-seaters, but the Velocity XLRG aims to satisfy both sides. It is a composite canard pusher with a wide cabin for 4 or even 5 occupants, a retractable tricycle gear, and Lycoming IO 540 engines in the 260 to 300 horsepower range, turning constant speed propellers. True airspeeds around 180 to 200 knots at altitude turn long weekend trips across several states into realistic plans instead of daydreams. With roughly 90 gallons of fuel on board, range at 65% power can exceed 1,300 nautical miles, placing genuine cross-country transportation firmly inside the experimental world. The pusher arrangement lowers cabin noise, while the canard's stall behavior gives families an extra sense of safety when thinking about children and grandchildren in the rear seats. Retractable gear adds maintenance and inspection work, but buys the cruise numbers that make a 4-seat experimental competitive with certified aircraft costing 2 or 3 times more. Composite layups, resin systems, and careful surface finishing replace classic sheet metal skills demanding that builders master a very different craft. Completed Velocity examples often sell between $130,000 and $220,000, proof that experimental aviation can finally deliver fast, efficient family transportation without surrendering to factory prices. Airline and corporate pilots spend entire careers in turbine cockpits while private ownership feels impossibly distant. Experimental rules quietly reopen that door, and for many builders, the turboprop becomes the holy grail of personal aviation. The performance Turbine Legend exploits this gap by packaging Walter M601 or Pratt & Whitney PT6A engines, producing roughly 650 to 724 shaft horsepower into a sleek composite airframe that can actually be assembled in a well-equipped hangar. Maximum speeds approach 309 knots, with cruise near 290 knots around 25,000 feet, far above the comfortable ceiling of most piston experimentals. Climb rates near 6,500 feet per minute shove the aircraft through weather layers and up to smooth, high-altitude air in minutes, while a service ceiling around 35,000 feet touches the lower flight levels, typically reserved for light jets. Extensive carbon fiber structure keeps weight in check, so that these performance figures are not just theoretical brochure numbers. Retractable landing gear tucks cleanly into the aerodynamic fuselage and wing roots, minimizing drag when high cruise is selected and every knot matters. Standard fuel gives a range of roughly 820 nautical miles, not record-breaking on paper, but covered at such speed that trip times rival much larger aircraft. Finished Turbine Legends usually command between $300,000 and $500,000, standing as the experimental endgame for pilots who refuse to accept that turbine ownership must remain the privilege of corporations and the ultra-wealthy. The Reno Air Races forged a specific kind of aviator who treats lap speeds like championship scores and worships velocity above all other virtues. For that personality, the Nemesis NXT is less an airplane and more a carbon fiber altar to pure speed. Every surface exists to cut drag. Every curve is tuned for airflow, and comfort or practicality are sacrificed without hesitation in pursuit of more miles per hour on the clock. It is a purpose-built race plane that still fits inside experimental home-built rules. Under the cowl lives a Lycoming TSIO 540, turbocharged and heavily modified from its base 360 horsepower to outputs well beyond 400 and sometimes pushing toward 500 horsepower in full race trim. With that power, a tiny high loading wing drives lap speeds between 355 and 370 miles per hour at Reno, and straight line passes have exceeded 400 miles per hour in level flight. Low speed handling and docility are simply not priorities in this design. Cooling systems are crafted around Meredith effect principles, using radiator airflow and exhaust to claw back some thrust instead of accepting drag as an unavoidable penalty. Building such a machine requires expert-level composite skills and a willingness to operate close to structural and power plant limits that would make most general aviation pilots nervous. The Nemesis NXT stands as the ultimate expression of speed obsession in the experimental world, embraced by a tiny group of true believers for whom nothing matters more than going faster than anyone else. Understanding yourself honestly matters more than impressive specifications or magazine test pilot enthusiasm, selling subscriptions rather than serving readers. Which experimental captured your imagination and matched your actual flying priorities? Share thoughts and comments, helping fellow builders avoid expensive mismatches. Did these personality profiles reveal truths about your aviation desires? Hit that like button if honest analysis beats marketing hype every time. Ready to explore more experimental aviation content separating fantasy from operational reality? Subscribe and activate notifications, ensuring you never miss investigations that save years and prevent expensive mistakes. Watch the videos appearing here on screen and stay with us. Bye-bye.